everyone, welcome to our channel. I'm Estella, and I'm Aditi. We both got 5s in AP Chem and will hopefully help you to do the same. Today, we'll be explaining gas laws. Button your lab coats, tighten your goggles, and let's get to it.
As we know, gases will spread out to occupy the shape of the vessel they're in. This means that the pressure and temperature of the surroundings are related to the volume and quantity of the gas. Let's start by defining these terms.
Pressure is measured by the frequency of particle collisions with the wall of the vessel. Temperature is the average kinetic energy of the particles. In other words, how fast they're moving.
Volume describes how spread out the gas particles are, and is dependent on the size of the container. And finally, quantity just refers to the moles of gas present. Let's take a closer look at the relationship between these terms and the equations that can be used to determine changes in quantities.
Boyle's law states that as the pressure increases, the volume decreases. Think about piping frosting. As you apply pressure, the frosting in the bag moves into a space that has less volume. Thus, if the initial pressure changes, this equation can be used to determine the new volume as well.
Gay-Lussac's law states that as temperature increases, so does pressure. As the particles move faster with greater temperature, they collide with the side of the vessel more often, resulting in higher pressure. Remember, temperature is measured in Kelvin.
Charles's law states that as temperature increases, so does volume, aligning with the previously stated laws.
These equations can also be combined as such.
Now let's move on to the ideal gas law. This law fails to hold true at extremely low temperatures and extremely high pressures. However, ideal gases will act in accordance with this equation. In AP Chemistry, you'll most often be dealing with ideal gases.
The ideal gas law is PV equals nRT, where P is pressure in ATM, V is volume in liters, N is moles, T is temperature in Kelvin, and R is the gas constant, 0.08206.
One final law to keep in mind is Dalton's law, which states that in a mixture of gases, the total pressure is equal to the sum of the partial pressures of the component gases.
To find partial pressure, you can take the mole fraction of the gas, which is the moles of one specific gas divided by moles of the total gas mixture, and multiply that by the total pressure.
Okay, now we know all of the gas laws. Let's do an example. Pause and try it on your own first, and then we'll explain it.
In a 5-liter container at 298 Kelvin, 2 moles of nitrogen gas are present. Find the pressure in ATM.
Okay, so first let's set up the equation so that P is isolated. To do this, divide by the volume.
So now we just plug in the numbers. N equals 2 moles, we know R equals 0.08206, T equals 298 Kelvin, and V equals 5 liters. Solving the equation, we get 9.78 ATM.
Nice. Now let's do a partial pressure example.
A mixture of 50 grams of oxygen gas and 50 grams of nitrogen gas has a total pressure of 2.3 atm. What is the partial pressure of oxygen?
First, we need to find the moles of each gas. Remember, oxygen gas is O2 and nitrogen gas is N2, so the molar masses will be doubled. 50 grams of O2 divided by the molar mass, 32 grams per mole, gives us 1.6 moles of O2.
50 grams of N2 divided by the molar mass of 28.02 grams per mole gives us 1.8 moles N2.
We need to add these moles to get the total amount of moles, which is 3.4 moles. To get the mole fraction of oxygen, divide moles of oxygen, 1.6, by the total moles, 3.4, to get 0.47.
Now, multiply this by the total pressure in order to get the partial pressure of oxygen, which is 1.1 atm.
Hold on, this is a lot to keep track of. Can I get a recap?
No, but you can get a re-wrap. PV equals nRT. Gas laws can't defeat me. Use partial pressure for a mixture of gases. Soon you'll master all your classes.